A stem plot is a slightly less common type of graphical display, but can be very useful, especially when we're getting into chapter 2 for various things. And that's exactly what we're going to do. We'll go ahead and make a couple stem plots, and we'll talk about how we can use them a little bit later. And a lot of different types of graphs can be useful for different situations. Obviously, usually the goal is a quick way of synthesizing the information, because having to read through a bunch of charts, especially in this case, it's not so bad because there's only 10 data points. But when there are frequently, when there's thousands, it's a lot harder. But anyways, a stem plot, basically, it's a way of organizing quantitative data based on the size of the numbers. It's essentially extracting the smallest digit from the largest digit. And I'll go ahead and just start making one and kind of explain how it works as we're going. But it says create a stem plot which displays their age. But basically, we have students that are in their 10s, 20s, and 30s. And it's kind of unusual to call them in their 10s. But if you know what I mean, some of our students, basically some of their ages start with 1, some start with 2, and some start with 3. And that's essentially what a stem plot does, is it separates the 10s place from the 1s place. So basically what I'm going to do is I'm going to write a line, kind of a vertical line, and on the left-hand side, I'm going to put all of the options for the first digit. We have 1, 2, and 3, that's it. There's nobody in their 40s or higher, and there's no one who is less than 10. And then in this, following it, we're going to list all of the options for the ones place, all of the singular, the digits on the very right-hand side, in order. So we had one 18-year-old, that was the youngest student, so we'll start with 8. And then we had 4 19-year-olds. We'd make sure to list every single iteration, because each number after them stands for a unique data point in the stem plot. Now, we have students in their 20s. There's one student who's exactly 20. Also, the data is arranged in a very column row sort of way when you're writing it. So I'm going to do my best to keep the alignment as I'm drawing them here. But we had a 121-year-old Francine, and then we had a 23-year-old and a 25-year-old. So we'd write just one of each of those. Again, only writing the second part of the digit in the row that starts with 2. And we had one 37-year-old student. So basically, that would complete our stem plot. And to those who aren't really trained to understand what it means, it can look like a very weird way to present the data. But basically, it's a way of listing it in order, and also it's sort of a visual way of saying, well, how many students are in their 10s, how many are in their 20s, how many are in their 30s. You can kind of imagine how it's similar to a histogram in that this will get longer and longer and longer the more that you have. Kind of like how here I actually designed the width of my brackets. But another way that we could have made a histogram was how many are between 10 and 19, how many are between 20 and 29, how many are between 30 and 39. And that would be 5, 4, and 1. And so you can kind of see how it's very similar to a histogram in that way, because of the length of those rows. And yeah, again, that this reads, I have 18, 19, I have one 18-year-old, 4 19-year-olds, one of each of these, 20, 21, 23, 25, and then one 37-year-old. And that's, again, the meaning of this stem plot. So you can also, another question you might be wondering is, well, what if the number is more than 2 digits? What if it's like we're dealing with hundreds or thousands? Well, to do a technical stem plot, you can have some alterations where you can do it differently. But typically what you'd always do is you'd only split off the last digit on the right-hand side, and then on the left-hand side, it would be every other digit. So let's say you had numbers such as 107 or 109, and then 132 and 136 and 138. This would be kind of the way you would write those. I'm just making up numbers off the top of my head if they were larger. But a stem plot is usually inappropriate for describing really, really large numbers, or especially if you have a ton of data points. Basically, I wouldn't really recommend using stem plots for those sorts of situations anyways. We could also, it doesn't say to do this in the notes, but let's go ahead and make a Stemplot for GPA, because you typically you make the separator between the ones place and everything else, but you could technically do it on the decimal point as well. So let's also graph our GPA using a Stemplot. And again, actually, we're just going to use it later. So here, between all of our students, they either have GPAs in the 2s or in the 3s, nobody below that. So on our left hand side, we just have 2 and 3. And then again, going from smallest to largest, we have 2.2, 2.4, 2.5. There's only 3 students whose GPA is in the 2s here: 2.2, 2.4, and 2.5. And you might be wondering, should I put a decimal point here or whatever? But we'll just leave it as is, and we'll know what it means, because sometimes you can have an implied units to it. But you could put the decimal point here if you really wanted to. And then for 3.0, usually you wouldn't write it as just 3, but it's written as just 3 in our table. But we would make sure to want to put that as 3.0 to make sure 0, not O. It's not an O, but people say 3.0, even though it's not really right. It's 3.0. You know what I mean? Sometimes I try to be funny, but I don't know if it is funny. Whatever. Then the next up would be 3.5, it looks like. 3.5 for Irfan. 3.6 for Gladys, and so on. It looks like we have one student with 3.7 GPA, one student with a 3.8, and then 2 students with a 3.9. And so that would finish our Stemplot. Another way to check yourself is make sure that there are this 10 numbers on the right hand side. We had 10 different students here. We want to make sure we have all of them 5, 9, 10, and then here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, that is a quick way to make sure I got all the data there. And here we can, again, kind of imagine this as a histogram. We have 3 students whose GPA is in the 2.0, or in the between 2.0 and 2.9, and we have 7 students whose GPA is between 3.0 and 4.0.